Welcome back to our story about what every software engineer should know about generative AI. In the previous video, we had a look at the current landscape of generative AI, and the next step in our journey to become AI-powered developers is to become effective users of generative AI. And as we argued, it's best to start by building some understanding and intuition of how generative AI works. And in this video, we'll start out by looking at how ChatGPT was built, and through that, sort of getting a better understanding of generative AI technology. And then we'll run through a bunch of examples and techniques, hopefully inspiring you to explore further. So note that this can only be a brief overview of the field of generative AI and how these kind of models work. And there are many excellent resources out there if you want to dig deeper. And for those of you planning to take my course DAT158 on deep learning engineering, know that you'll learn a lot about natural language processing and how LLMs are built, and you'll actually get the chance to build your own large language model from scratch. So ChatGPT, how was it created? Well, here's a very simplified recipe. First off, you need to have an objective. And the objective that OpenAI, the creators of ChatGPT, set forth was to create a chatbot that's helpful, honest, and harmless. Sounds like a good plan, right? But, however, honesty is quite a tricky concept. How do you know if someone or something is being honest? Well, you need to have some understanding or a solid model of the inner thinking of that person or thing, because honesty is related to the discrepancy between what the entity or person is thinking and what is being what's coming out of the person or entity. Okay, but the inner thinking or the thoughts of the kinds of AI models we're talking about here are completely opaque. They are completely black boxes. That means that measuring honesty doesn't really work, right? So what do? Well, what OpenAI did was simply replace honest with correct, which is something completely different, of course, but at least it's measurable. And being correct is also a nice feature to have in a chatbot. And with that taken care of, we can start. The first step is to use a so-called large language model. And the task of a large language model, or an LLM, is to predict what comes next in a sentence or what is missing from a sentence. So your phone likely has a predictive text feature, like my iPhone's feature that I've shown here. When I entered "the pedestrian crossed the phone helpfully suggested bridge, road, or street. And when I changed pedestrian to plane, the suggestions changed to border, runway, and skies. So in other words, the software powering this feature knows, in scare quotes, how pedestrians and planes tend to behave, and also that they behave differently. This is what a language model must know to be able to insert what is missing in a sentence or to predict the next word. So how do you train a large language model to give it the necessary knowledge about language and concepts and entities in the real world? Well, you need data. And where do you get data? Well, you download a big chunk of the internet, and then you remove words at random. So that's your training data. The machine is tasked with reinserting the removed words, and you know what you deleted, so you can assess how correct how well the machine performs the task of reinserting words. You know what should be there, and you know what the machine put there, and then you can use the discrepancy between what should be there and what the machine put in as a feedback signal to a training process that lets the machine learning model improve. So you have lots of training data. So now you only need a machine learning model that is capable of representing words and concepts and entities from the real world to such an extent that it can solve this task. And it's very important to stress once again that this task is extremely difficult. It's easy to forget how difficult this is for us, because we know, or we can easily guess what comes next here. But why are we able to do that? Well, because we have some understanding of language and also of the real world. So we know that planes rarely cross the street, for example. So here's an illustration that is very important to get a feeling for how these kind of models work. So let's take a closer look. Here we see an illustration of the kinds of associations between words and concepts learned during training. And note that this isn't the same model as the one behind ChatGPT, but keeping this mental picture in mind is very helpful for understanding. Each dot is a word. During training, the model learns to represent words that somehow belong together similarly. So if you click a word, here I clicked artist, we can see that the model's representations of the word is similar to the ones for, say, musicians, performers, composers, writers, and so on. Even if the words as such, in terms of the letters and so on, are very dissimilar, the concepts are associated. And this whole thing is automatically learned during training. And it's, of course, a very valuable representation. A representation that can be used when a model is, for example, tasked with predicting the next word of a sentence. So associations, that's a key concept for understanding language models. So now that we have a model that can somehow represent words, entities, and concepts from the real world, we can start to turn it into a chatbot that can answer queries and discuss with users. First, we collect a set of questions and answers to be used to fine-tune the model further, to train it further. Until now, we haven't given it a clue about what we're after, but with some question and answer examples, we can get it started on a good path. So where do you find these examples, by the way? Well, OpenAI has had an API open since the release of the older GPT-3 model series in 2020. And via this API, they've collected a bunch of examples of questions and answers. So we provided them with the training data. Once the model has been fine-tuned for a bit, we ask it to provide multiple different answers to a couple of thousand questions. And then we ask someone, some humans, to rank each of the answers to each question from worst to best. And where do we find such humans? Well, OpenAI hired them via Upwork, among other things. So now we have a couple of thousand questions, each with a bunch of possible answers, and the possible answers are ranked from worst to best by humans. So what then? We can't keep asking humans to do this, right? That is not sufficiently scalable. So what do? Well, we are machine learning engineers. So of course we train a machine to do the ranking for us. The humans just provided us with the training data. So this is now feasible, right? And once that's done, we have something highly scalable. We can ask the fine-tuned model to propose answers to millions of questions. And then we have our model that is mimicking the human raters rank the answers from worst to best. So along the way, we can meet tricky examples. So we set up a way to find the questions and answers where the model will learn the most if humans rank the answers, right? And then we give those to the human raters as we go. And it will be done, or it was the same raters as before. So then comes a crucial step. We make the system publicly available as a web app, and we call it ChatGPT. So what was a big surprise even to OpenAI was that it would become immensely popular almost immediately, the fastest growing software product in history, once they released ChatGPT as a web app. That means it has a lot of users. And we can task the users with providing feedback that can be used for further training and tweaking of the system. And if you've used the system, you probably noticed the small thumbs up and thumbs down icons, right? And if you click them, say you click thumbs down, what are you asked? Well, whether the response is helpful, correct, or harmless. And you're also asked, like, what would the ideal answer have been? this would be gold for OpenAI if you gave them this, right? And this is actually worth so much that even if you hit thumbs up, you're still asked what would the ideal answer have been. So there you have it, ChatGPT. Clearly, ChatGPT is the most well-known large language model and chatbot, but it is powered by what is currently the best model, this GPT-4, but it's far from alone. And furthermore, the same ideas and models that powers this chatbot can be used for more than text generation, as we've seen. So generative AI is more than ChatGPT, and generative AI is more than large language models. Here are a few examples of generative AI technologies and solutions, and I recommend that you try out all of them and whatever else is out there. You really need to experiment to get a sense of what's going on. And one thing to keep a special eye out for these days is Google's upcoming Gemini model series. Here's a ranked list of some direct competitors to the GPT models of OpenAI. And many of these are open source, which is a huge advantage for certain things. You can install them locally, and they're relatively easy to fine-tune for specific tasks. But none of them perform as well as the OpenAI proprietary models, but the gap is closing. And by the way, when you look at such rankings of models, you should be aware that it's not that easy to evaluate large language models fairly. They are very sensitive to how you formulate the prompts. They can be contaminated by training data, meaning you may end up evaluating them on tasks and the data that they've already seen during training, and therefore they may be uninterestingly good at this task. And some of the training data from the open source models are input-outputs grabbed from GPT models. And that makes the comparison between the open source models and the GPT models misleading to a certain extent, and so on. So evaluating LLMs is a bit of a minefield. So let's move on to some examples. And once you start experimenting with these kind of systems, you realize that generative AI models are weird. What are their capabilities? Well, nobody knows. How do you use them optimally? No one knows. So when exactly do they fail? No one knows. For which tasks do they work well? No one knows. So this is very interesting and also hugely relevant for us when we start building software on top of these weird objects. So given this, the only way forward is to experiment. You need some preliminary answers to these questions, right? And the best way to get a sense of what works and doesn't work is to try it out. So let's proceed.